This video is part 2 of the work solutions of the Unit 1 Methods 2021 Exam 2. Let's get stuck into it. Mr. Tench sails his yacht in a straight line from the origin to 810, then turns 90 degrees and sails in a straight line to C, which is directly east of A, and completes the triangular course by sailing back to A. So it goes back to here. So basically he's done this. Find the equation of the straight line AB. So that's the equation of this line. So that's fairly easy to do. We can see already that the y-intercept is 0. So what we'll do is just note that as x increases by 8, the y values go up by 10. So it's going to be 10 on 8. So y equals 10x on 8, or y equals 5x on 4. You could also just punch it out with a gradient formula if you're not too sure. 8, 10, and 10 take away 0, 8 take away 0, etc., etc. So do the y2 take y1 thing. Okay, find the equation of the straight line BC and hence show that the coordinates of point C are 41 on 2, 0. So C is the x-intercept. So basically what I'm going to do is find the equation of this line here and then let y equal 0 to get the x-intercept, which should be 41 on 2. So what do I know about this line here? It contains the point 8, 10, and its gradient is going to be the negative reciprocal of this line here because it's perpendicular. So M1 was 5 on 4, I think. 5 on 4. So the new line, so M of BC, is going to be negative 4 on 5. And what was the other thing we're going to do? And it contains the point 8, 10. So we'll go y equals negative 4x on 5 plus c sub 8, 10. 10 equals negative 32 on 5 plus c. Let's add that to that. So we've got 50 on, no, 100 on 5 times 5 over 5, no, 50 on 5, I was right the first time, plus 32 on 5 equals c. C is equal to 82 on 5. So my equation is y equals negative 4x on 5 plus 82 on 5. Now let's get the x-intercept when y equals 0. So times by 5. Yeah, this is looking good. That is going to be divide by 2, 41 on 2. Therefore, point C is 41 on 2, 0 as required. Total distance in km of the triangular course. So that's 41 on 2. That is going to be from there to there is going to be 8. From there to there is going to be 10. So what I'll do, I need to work that out, and I need to work that out. So this is going to be Pythagoras. So the hypotenuse is 10 squared plus 8 squared. Root 41. So that must be 2 root 41. Now, how are we going to get that? Well, what I think I'll do is just to work out that hypotenuse, I'm going to go c equals square root of. So this length here is going to be 41 on 2, take away 8. So this is going to be 41 on 2 take 8 all squared, and this is going to be 10 squared. C equals so that's going to be 5 root 41 on 2, 5 root 41 on 2, and this length here we know in total because that's the origin, 0, 0, it's just going to be 41 on 2, so we're going to say that distance is equal to 2 root 41 plus 5 root 41 on 2 plus 41 on 2. Okay, so it's that plus that plus 41 on 2. Simp that. No, that's the best we're going to get. Distance is 9 root 41 on 2 plus 41 on 2 km. Didn't need unit because it was in the question. Find the area in kilometres squared of the shape formed by the journey of Mr. Tench. So this is the base. So area equals half base times height of a triangle. So the base is 41 on 2, height is 10. So what's that? That is going to be area equals, that's 410 on 2. On 2 times a half, area equals 410 on 4. What's 410 on 4? I can't be bothered simplifying that. Shift. Okay. Kilometres squared. Again, didn't need the unit because it was stated in the question. Mr. Tench's yacht breaks down at X, halfway point between this. A rescue boat located at A sails directly. Find the exact coordinate of X. Okay, so that's 810. We know from before this is 41 on 2, 0. So all we need to do is just find the midpoint. Yeah, it's not too bad. So that is going to be 8 plus 41 on 2 on 2 and 10 plus 0 on 2. So that's going to be 16 on 2 plus 41 on 2, all on 2 and 5. So that's going to be 41, 51, 57 on 2 on 2, which is 57 on 4, comma 5. Alright, question 1 done, I think. This page is blank, so hopefully you folded out your booklets so you could see the whole thing. That's why we put the blank pages in there. Okay, f of x is x squared. Describe a set of transformations that move f of x to the function that. So this is a translation 2 units left and 1 unit down. Okay, sketch the graph of that. Okay, so the turning point is at -2, -1. That's there. It's upright. So let's get the x-intercepts, which occur when g of x is 0. -1 take 2 is -3. +1 take 2 is -1. So nice clean values there. -3 and -1. Okay, and what we wanted is from -2 to positive infinity. So it's going to go up through there. What's the y-intercept? So y-intercept occurs when x is equal to 0. 4 take 1 is 3. Okay, so it's basically going to go like that. So key features, 0, no, not 0. Oh, -2, what's that, -1. X-intercept was -1, 0, and this one was 0, 3. State the domain and range. Well, the domain is just -2 to infinity as stated in the question, and the range of G is going to be this value here, which is -1, and it's inclusive of it, to positive infinity. So explain why G of -1 exists, because G of X is 1 to 1 function, is a 1-to-1 function. State the domain and range of G -1x. So that's just going, so what's going to happen is, because we swap x and y for the inverse, these will swap around. So that is going to be, so we're going to say that dom G -1 is equal to the range of the original, which is -1 to infinity. And the range G -1 is equal to, what was it, -2 to infinity, I think. Yep. Find the rule G -1 x. You don't need to include the domain, and sketch the graph, clearly labeling coordinates of endpoints and intercepts on the same Cartesian provided on the previous page. Bucket loads of marks. All right, well, let's sketch the graph first, and believe it or not, we can without the function. So what's going to happen is that these points here will all swap x and y. So we're going to have, if this is the point on the original, -2, -1, then on the inverse, it's going to be -1, -2. So here is -1, and here is -2. So there's one of the points. Now this one's going to be 0, -1. So 0, -1, that's there. And that's going to be 3, 0, which is there. So let's label each one of them. That's -1, -2, 0, -1, and 3, 0. So there's our inverse function, which you can see is reflected along the line. Y equals x. So you can see that. Didn't need to include that, but I did that for effect. Okay, so find the rule. So let's just write the rule for G of x is equal to x plus 2 all squared, take 1. Oh, I forgot that already. X squared, x plus 2 all squared, take 1. So we're going to go, if y is g of x, then x goes on in place of g of x, y plus 2 all squared, take 1, x plus 1 equals y plus 2 all squared, y plus 2 equals plus or minus root of x plus 1, y equals plus or minus x plus 1, take 2. So we've got two possibilities here, and the one that we're going to accept is the positive, and the reason for that, so we're going to say but y is equal to x plus 1 take 2 as the range of the inverse. Okay, so the range of the inverse is -2 to positive infinity, okay, which is the top half, as range of the inverse, which is g, is Okay, so therefore, finally we'll say g negative 1 of x is equal to x plus 1, take 2. Okay, let f of x equal that over this domain. Write down the minimum value of f of x. So it occurs at negative 2. So I'd start this one up with a define f of x equals 2x cubed, take 9x squared plus 7x plus 6. And we'll do f of negative 2, negative 60. Find and hence add the x-intercepts of f of x to the graph above as coordinates. So f of x equals 0, x is equal to 2, 3, and that. So that one there is negative 1/2, 0. That one there is 2, 0, 3, 0. The graph of f of x has 2 turning points. Label the turning points with coordinates. Your ordered pairs can be written down correct to 2 decimal places. Okay, so what we'll do is where's graph and table? We'll graph f of x. Okay. So what we need is that turning point there. Okay, so I'll just stretch that out a bit. Okay, so the way I'm going to get it is analysis, gsolve, and max, which will get me my local max, which is there. What's it going to be? 0.46, comma 7.51. And let's grab the min, analysis, gsolve, and min. So that's that one there, and that's going to be 2.54, negative 1.51. Alrighty. So label the turning points with coordinates. Now, look, the other way you could do this, if you're asked for exact values, so you didn't have to do this, is interactive calculation and run fmax. And what you'll do is find the maximum value, shift and for f of x between, what is it, negative 1/2 and 2. So 0 and 2. What this will do is give you the exact value. So the max value is actually that, which you'll note, if I approximate it, is 7.51, which is what the calculator gave me approximately. Right, how many x-intercepts will the graph of g of x equals f of x plus 2? So what that will do is shift that graph up 2 units. Okay, so it's basically going to send this graph up 2 units. And what that will do, if you note that the y value of this maximum is negative 1.51, if I add 2 to that, it's going to send it above, which means that that is going to go up and it will be above the line. So in fact, this is going to have 1 x-intercept. No fancy algebra, just look at the graph. Okay, the graph of f of x is translated to give the function h of x equals f of x plus b. Alright, if h of x has an x-intercept at 1, 0, find the possible values of b. Right, so what we need to know is that h of x is based on this graph here, f of x. Alright, it's based on this graph here. And what we want it to have is an x-intercept at 1. Alright, now it currently has an x-intercept at 2 and 3. We want one of these and negative a half. So we want it to shift left. So we can go left 1 unit. We could also go left 2 units. And we could go right. What's that? That's 1, 0. So 1, 1.5. 1.5 is 3 on 2 units. So these are the 3 possibilities. Now we can test this out as well. So what I'm going to do is go back to the graph screen. So I'm going to do f of x, and to shift this 1 unit to the left, I'm going to do f of x plus 1. Okay, and what should happen is the graph should have an x-intercept there. It does. Now I should get the same result. Should have an x-intercept of 1 if I go f of x plus 2. Yep, there it is there. And f of x take 3 on 2. So 1 as well. So if h of x has an x-intercept, find the possible values of b. So b is equal to 3 on 2, negative 3 on 2, positive 1 and positive 2, I think were the other ones. Where are they? 1 unit and 2 units. Yeah, positive 1 and positive 2. Okay, state the largest set of values for b for which the graph of h of x has 1 positive x-intercept. Okay, so this is pretty hard, this. So h of x is f of x plus b. So let's go back to f of x untransformed and graph that. So there it is there. And what we want to have here is 1 positive x-intercept. Okay, so basically what we want to do is shift it to the left 2 units. So what I'm going to do is f of x plus 2, which is shifting it to the left 2 units, and regraph. Alright, now if you note here, what's happened is that it has 1 positive x-intercept now. That's the only positive x-intercept. The other is at 0. So this meets the requirements. So b, so the lowest value, so b is an element, we can start at 2. Okay, so 2 is the lowest value that it can be, and what we can do is keep shifting until this value here is 3. Okay, and I'll show you what I mean. So what I'm going to do is change this to a 3, regraph it, and there it is there. Now the only thing is, if I actually include 3, so if this was squared off, that would mean that that would happen, or that x-intercept would be at 0, which would mean that there's no positive x-intercepts. So what I can say is that one's going to be curved, which includes all the values between 2 and 3, inclusive of 2, but not including the 3 itself. Okay, j of x is equal to 1 over f of x. State the implied domain. Ooh, okay, so j of x equals 1 over, now what was f of x again? So f of x was this, which in factorized form will have intercepts there. So here's what I'm going to do to get this one. What I'm going to do is factorize f of x. I'm going to go menu, action, transform factor, f of x. Okay, and what we'll do is we'll say where x is an element of all real numbers, but we're going to remove some sets, some things from that. It's when this one's equal to 0, because if this is 0, then it's 1 divided by 0, which is undefined. So we're going to remove 2, we're going to remove 3, and we're going to remove negative a half. So that should be first. Oops. Okay, so it's all real numbers except -0.5, 2, and 3, because all three of these will cause divide by zero errors. Okay, during her long service leave, Ms. Lowinger attended a holiday resort. At the resort, guests could choose to participate in clay shooting or archery or both activities. On one particular day, Ms. Lowinger noticed that 40% of the guests participated in clay pigeon shooting, 75% attempt archery, 20% try clay pigeon shooting but not archery. So clay pigeon shooting and not archery is 0.2. Attempt archery is 0.75. Clay shooting 0.4. What is the probability that a randomly selected guest participates in neither? That's that one there. Both. Archery but not clay pigeon shooting. Archery but not. These are so easy with a two-way table. Clay pigeon shooting, given that they participate in archery. Right, so what we know is that they participated in archery, so that means that that's the sample space, so it's going to be clay pigeon shooting, so it's actually clay pigeon shooting, it's the intersection over the total. So it's going to be 0.2 over 0.75, which is equal to 20 over 75, which is equal to 4 over 4/15. Okay, and on to the final question. The curve with the equation x cubed is transformed to become this. So just by recognition, we can see that this is a reflection in x. This is a dilation 2 from x. It's translation 1 left and trans 4 up. Okay, so we want to put this into a matrix. Okay, so x dash x y equals a matrix times x, which is plus that. Okay, so reflected in the x changes y, so that's going to be negative down here. Dilation 2 from x changes y, so that's going to be 2. Trans 1 left, so the rest of this matrix here looks like that. 1 to the left means that should be a -1, and that should be a 4. Okay, so A equals 1, B is -2, C is this thing, -1, and D is 4. Okay, sketch the graph of g of x, labeling any axes, intercepts, and the point of inflection. So g of x equals 4 take 2 x plus 1 cubed. No domain restriction, no. Okay. So negative and up, so -1 and 4, so there it is there, that's the inflection point. So the standard inflected cubic looks like that. This is reflected, so it's going to look like that. So it's going to come down like this. x-intercept and y-intercept. It's going to have, yeah, one x-intercept, one y-intercept. So we'll do the y-intercept, 4 take away 2, 1 cubed is 2. So there is the y-intercept. So it's going to come down through there and go through somewhere there. So let's get the x-intercept. Yep, the x-intercept. When g of x is equal to 0, 4 take away 2, x plus 1 cubed. Negative 4 over negative 2 is 2. 2 to the 1/3 or the third root of 2, whichever one you want. X is equal to 2 to the 1/3, take 1. We can get a decent approximation of that from here. So we'll go 2 to the power of 1/3, take away 1, 0.259. So roughly a quarter of the way through. Right, so let's do our best effort at this. So it's going to sort of come down. That's not a best effort. Oh, I'm reasonably happy with that. Yours should be a little bit smoother than that. Key features, 0, 2, 2 to the 1/3, take 1, comma, 0, negative 1, comma, 4. Okay, the diagram below shows a rectangle drawn in part of the graph of g of x. So it basically is focusing on this part here. That's the part we're talking about. Okay, so that's like 0, 2. That's 2 to the 1/3, take 1, comma, 0. That's the x-intercept and y-intercept there. Okay, find g of a. Okay, so g of a equals, so all this is saying is put a into the function, where the function is that. Just going to copy the function so I don't have to keep scrolling. How do I do that again? So g of a is equal to 4 take 2, a plus 1 cubed. Hence label the coordinates. Oh, what does that say? Can I move that? Of P on the graph above. So here's P. So it's going to be a comma 4 take 2, a plus 1 cubed. State the value of b, so it's this value here, in terms of a. So b is just the y value here. It's just 4 take 2, a plus 1 cubed. That's all b is. So this value here is the y value there, which is this value. Write a function a of a which gives the area of the rectangle. So a of a is equal to length by width. Now it needs to be in terms of a only. So it's going to be this value here, a, multiplied by b. And we know that b is just this. So it's going to be a times 4 take 2, a plus 1 cubed. So there's my a of a function. The graph of a of a appears below. Find the maximum possible area of the rectangle correct to 2 decimal places. So that's just going to be that maximum value there. So if I just graph this function here and run an fmax on it, oh no, not even fmax, just max, I can get it to 2 decimal places. So let's go ahead and do that. So menu, graph, x times 4 take 2 brackets x plus 1 all cubed. Well, let's have a look. So there it is there. So we can narrow down our window just to see it the way the graph has it. Alright, that looks pretty similar. So we'll go analysis, gsolve, and run a max on it. Okay, so the max is 0.15, correct to 2 decimal places. And it's an area, so it's in centimeters, is it? Centimeters squared. Okay, if B of A equals A of A on 3, state the value correct to 2 decimal places of A for which the maximum value of this function occurs. Alright, so this is a tricky one to understand really easy once you actually get what it's saying. So B of A is a new function. Now what this represents here, if you drop 1/3 of A into A of A, all that is a dilation factor 3 from the y-axis. Okay, so what's going to happen is this function here is going to be dilated by a factor of 3. So originally this value here was 0.145 ... whatever it is. When it gets dilated, all that's going to happen is this value here is multiplied by 3. So all I'll do to get this one is note that it's going to be this value here. I think I can copy that. Go into main and go that times 3. Alright, and so it'll just move it over by a factor of 3. So all it will be is 0.44 centimeters squared. Not the value, actually, it's the value, so I don't need the unit. Alright, and that's it. Alright, there you go. A couple of tricky ones to finish with for sure.